knows they are what now? They are two different things. Alright? So I'll talk about what? Terminal potential difference. I just call it terminal PD. So what is terminal PD? This is the potential difference. The potential difference when the cell or the circuit cell is delivering current. And I'll show you soon that V, this particular V is equal to what now? IR. I'll show you this when I explain what now? Ohm's law. Terminal potential difference is what now? The potential difference when the cell is delivering what now? Current. Why what now? The other one is called electromotive force. Electromotive force. Electromotive force is also referred to as EMF. Note that. So which one is electromotive force? Electromotive force is the potential difference when the cell is not delivering. It's not delivering current. So what does that mean? Now that it is open, the potential difference in this what now, in this system, is referred to as electromotive force. The electromotive force is the potential difference in the cell now, why it's not delivering what now? Any current. However, if I close the cell, if I make it complete, I close the switch, the potential difference that's in operation right now is what now? The terminal what? PD. Take note of that. And then electromotive force, let me do this. I hope it works quickly. Okay, and let me take this upward. I want to explain something and I hope you will get it. Electromotive force E is equal to the terminal PD plus IR. Note, IR is called the lost voltage. IR is called the lost voltage. Why do we have IR? For the cell to generate, because the cell is the source of power for the circuit. For the cell to generate power, the cell also needs to work. So the process of the cell producing what now? The power required for the circuit, it has to work on itself. In the process of it, the work done in the cell, that is where this loss comes from. So the cell has its own resistance. Okay, I think I'm jumping a bit. Everything I'm saying now, you will get it better when I go to Ohm's law and explain resistance. But just follow the flow. The cell has what we refer to as internal resistance. This area is what now? It's internal resistance. So within the cell, there's work to be done. There's loads to be overcome within the cell. And that work that is done in the cell is not delivered to the circuit. So I can imagine it, or we can imagine it to be what now? A wasted what now? Wasted effort, in a sense. But without that effort, the cell will not what now? Will not power the what? The system, or power the circuit. So this internal resistance times what? Times the current will give you what's referred to as what? As a lost voltage. Since it's not coming into the what now? Into the cell. Then the one that goes into the cell, remember we said it's what? It's terminal what? Terminal PD. So if you want to find the value of electromotive force, it's going to be terminal PD plus what now? Plus this lost voltage. Is that okay? Now if I'm going to come back here, let me run back to what now? To explaining Ohm's law very quickly. Okay, let's talk about Ohm's law. What is Ohm's law about? Holmes did an investigation of the relationship between potential difference and what now? And current. And then he found out that every time the potential difference is increased in the cell, the current delivered is what now? Is higher. And every time the potential difference is reduced, the current delivered is what now? Is lower. So it's evident that what? Potential difference is directly proportional to what? So the current. That means if we introduce what? A constant of proportionality, we can bring what now? The equal sign. Alright? And we found out with time that this constant of proportionality is equal to what? So the resistance. So what is resistance? That was what was causing my trouble a little earlier. What is resistance? Resistance is simply opposition to flow of electrons. Opposition to the flow of what now? Electrons. And every system, everything that conducts electricity has a measure of what now? Of resistance, right? The resistance that is posed by the system, by the conductors and all that, right? There's no system that does not have what? A level of resistance. Are you with me? Okay. This simply means that what? V will be equal to what now? Current times what? Resistance. I'm arranging alphabetically. Current times what? Resistance. Potential difference. This is from Ohm's law. Ohm's law states that what now? The potential difference is equal to what now? Current times what? Times resistance. And then we have said some things in the past, so I'll rush over and then run over them again. Let me go forward a bit. Coming back here, since I know that current V is equal to IR, I can use IR to replace what? V here. And if I do that, I'll get this. So my W will be equal to this. So I can have a new formula for what now? For work done. That is work done to be equal to what? I times I is what? I squared. So this is another formula I can use in place of what now? For work done. Okay. So I have an additional formula, but it's the same thing. If you are calculating and what you are giving under examination condition is current and resistance, you use this formula. If it is current and PD, you use this formula. We can also make what now? I the subject here. If I make I the subject, I'll get V over what? V over R. I will go to V over what now? R. So if I use this V over R to replace I here, in this place, I will have that what? IVT becomes what? V over R, V what now? VT. This is IVT now, right? So V times V will give me what now? V squared times time, all over what? All over R. This is another formula I can use. So I'm having a third formula here, which is going to mean that what? The same work done is equal to what? V squared over time. Sorry, V squared times time, all over what? All over R. So in case you are giving the PD and then you're giving what now? Resistance, you can use this. If you are giving what now? Current and you're giving the PD, you can use this with time, of course. Then if you're giving what now? Work done, they're giving current and what? And resistance, you can use this formula. Now let me show you something very quickly. Before I digress, before I go back, look at this. We know that power is giving us what? Sorry. Power is equal to work done over time. The rate of transfer of energy, work per unit time, is what now? Is power. What am I saying? Work is the, I just got this upside down, sorry about that. Work is equal to power over time. Oh, wow, what's happening to Joseph? What's happening to Joseph? I'm telling everything upside down. I was correct. The initial thing I said was right. Sorry about that. Okay. Maybe I'm hungry. Okay, power is equal to what now? Work over what? Over time. And if this is true, I can say that power, what is work there? IVT, that's work, right? Over time. Time will cancel time. So power becomes what? IV. I can use the other one. I'll have what? I what now? Squared RT over time. Time will cancel time. I have I squared times R. I can use the last one where I have what now? V squared C all over what now? R divided by time, it will cancel out. So I get V squared over what? Over R. What I just want to establish is the fact that power can be easily gotten from what now? From the formula we have for work done. All you just need to do is to remove the T. If you take away the T, we get what now? You will get power. Let's do that again. So if I take T from the first one, I'll get what now? IV, this is 1. Power is also given as what? I squared R, this is 2. Power is also given as what? As V squared all over what? R, this is what now? This is 3. So I can use this to find power for an electric system, and this for what now? The power for what now? The power in the circuit, and then this is what work done in the circuit. Is that okay? If I'm a little too fast, please, you can rewind, go back, and then what now? Make it watch it at your convenience, or go through at your own convenience. Let me run back to this point. I hope you remember what we did here. We have said that what? That electromotive force is equal to what? Voltage plus what now? Plus voltage. The voltage in the circuit, that's the terminal voltage, plus the voltage in the what now? In the cell, which is the lost voltage. We have also said that V is equal to what? This R here is the resistance in the circuit. The resistance in the circuit is this R. Alright? So I can have that, and if this is true, I can also say that E, using this to replace V here now, I can have I with a big R plus what? I with a small r. The small r is internal resistance, while resistance in the circuit is what now? Big R, equivalent resistance actually. If I is common, since I is common right now, I can have this. So I can use this formula to calculate what? EMF. I can use this formula to calculate what? EMF. I can use this to calculate terminal PD. I can also use this to calculate what now? EMF. Whichever is convenient for me. Alright? So I'm going to pause here for a while, and then I'll explain some other things afterwards. Is that okay?